Good day. I welcome you at the lecture on quality of water. Another subject, environmental engineering, and the related subject code is CE701 and the module number is 3. Myself, Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management, JIS Group. In this lecture, we will be covering these following topics, that is the details of water quality index and various standards of parameters for potable water. Now let us proceed to the lecture. Water is essential to sustain life and is satisfactory, that means adequate, safe and accessible supply must be available to all. Improving access to safe drinking water can result in tangible benefits to health. Every effort should be made to achieve drinking water that is as safe as practicable. Safe drinking water, as defined by the guidelines, does not represent any significant risk to health over a lifetime of consumption, including different sensitivities that may occur between life stages. Those at greatest risk of waterborne disease are infants and young children, people who are debilitated, and the elderly, especially when living under unsanitary conditions. Those who are generally at risk of waterborne illness may need to take additional steps to protect themselves against exposure to waterborne pathogens, such as boiling their drinking water. Safe drinking water is required for all usual domestic purposes, including drinking, food preparation, and personal hygiene. The guidelines are applicable to packaged water and ice intended for human consumption. The World Health Organization considers access to safe drinking water a basic human right. About 1 to 2 billion people lack safe drinking water, a problem that causes 30,000 deaths each week. More people die from unsafe water than from water, as stated by General Ban Ki-moon, the UN Secretary General, in 2010. Drinking water, also known as the potable water, is water that is safe to drink or to use for food preparation. The amount of drinking water required to maintain good health varies and depends on physical activity level, age, health-related issues, and environmental conditions. Americans on average drink 1 liter of water per day and 95% drink less than 3 liters per day. For those who work in a hot climate, up to 16 liters a day may be required. Typically, in developed countries, tap water meets drinking water quality standards, even though only a small proportion is actually consumed or used in food preparation. Other typical uses include washing, toilets, and irrigation. Grey water may also be used for toilets or irrigation. Its use for irrigation, however, may be associated with risks. Water may also be unacceptable due to levels of toxins or suspended solids. So, you can see that there are certain number of general parameters which are responsible for safe drinking water. In our current study, we will try to focus on certain number of parameters and their standard values which are required for safe drinking water. In this regard, water quality index is an important issue. Water quality index, that means WQI, is a mean by which water quality data is summarized for reporting to the public in a consistent manner. That is, it tells us in simple terms what the quality of drinking water is from a drinking water supply. Basically, it is an important tool to determine the drinking water quality in urban, rural, and industrial area. WQI is defined as an index reflecting the composite influence of different water quality parameters, which is considered and taken for calculation of water quality index. It provides a single number like a grade that expresses overall water quality at a certain location and time based on several water quality parameters as indicated and discussed before. The objective of an index is to turn complex quality data into information that is understandable and usable by the public. In point of view from India, this is very much important because it has been confirmed by the Composite Water Management Index of Niti Aayog that 70% of India's water supply is contaminated. It is found that globally, India is ranked 128th among 122 countries in WaterAid's Water Quality Index. So the importance of Water Quality Index is that water quality can be monitored over a period of time in order to detect changes in the water's ecosystem. Water Quality Index was first developed by Horton in 1965 to measure water quality by using 10 most regularly used water parameters. The method was subsequently modified in the later stages by various experts. The indices used water quality parameters which vary by number and types. So, from our discussion, we can understand that water quality index is a very much important tool for assessing the water quality, which depends upon certain parameters. Different countries use different parameters for this assessment. Following are the most commonly used parameters globally for the determination of water quality index. So the parameters are which are most commonly used globally are biochemical oxygen demand, dissolved oxygen, fecal coliform, nitrates, pH, change of temperature, total dissolved solids, total phosphate, turbidity. In India, for the calculation of water quality index, these particular parameters are taken into account, that is turbidity, color, total dissolved solids, pH, DO, BOD, Secchi depth, total hardness, chloride, fluoride, nitrate, total phosphate, iron, sulfate, arsenic, total coliform. So altogether there are 16 numbers of parameters that are used for the determination of water quality index. Together they form a composite number based on which quality of water is categorized into 5 classes. If the score of water quality index is between 95 to 100, then the water quality is considered as excellent. If the score is around 75 to 94, then the water quality is considered as good. If the water quality index value is between 50 and 74, then the quality of water is considered as fair. If the value is between 25 and 49, then the water quality is considered as poor. And if the water quality index value is in between 0 and 24, then the water quality is considered as heavily polluted. So we can see that for the calculation of water quality index, there are 16 numbers of parameters have taken into account. For excellent quality of water, the value of turbidity should be within 5 NTU. The measurement of color should be within 10 Hazen unit. The total dissolved solids measurement should be within 500 mg per liter. pH should be within 6.5 to 8.5. Whereas dissolved oxygen concentration should be within 8 mg per liter for the excellent quality of water. For excellent quality of water, BOD concentration should be within 2 mg per liter. In this scenario, the safety depth should be equal to or more than 10 meter. Total hardness should be less than 300 mg per liter for the case of excellent quality of water, and for the chloride concentration it should be within 200 mg per liter. For fluoride concentration, in case of excellent quality of water, its concentration should be within 0.7 and 1.5 mg per liter. For nitrate concentration, in case of excellent quality of water, the value should be within 10 mg per liter. For total phosphate, the concentration for excellent quality of water should be within 0.02 mg per liter. For allowable concentration of iron, in case of excellent quality of water, the value should be within 0.1 mg per liter. For sulfate, the value of iron sulfate concentration for case of excellent quality water is within 25 mg per liter. For arsenic concentration in case of excellent quality water, the value should be within 0.005 mg per liter. And for total coliform, the concentration should be within 50 mpn in case of excellent quality water. For each and every property here, which are taken into account for the calculation of WQI, that is water quality index, the value of each parameter gets degraded as the quality of water gets degraded. So from this table you can see that each and every parameter gets degraded while the quality of water gets degraded. Suppose for pH, whereas for the excellent quality of water, the value should be within 6.5 to 8.5. In case of good quality water, the acidic limit should be within 6.0 to 6.4 and the alkalinity level should be within 8.6 to 9.0. So alkalinity is more than 8.5 with respect to excellent quality of water, and the acidic level is less than 6.5. For the fair quality of water, you can see that the value of pH is less than 6, that is 5.9, and considered up to 5.5, whereas for the alkalinity level the value is greater than 9, that is for the good quality of water, and up to 9.5. So as the quality of water degrades, each and every parameter gets degraded individually. All these values and standards have been acquired from IS 10,000 and 500 1991 and Central Pollution Control Board, that is CPCB. Also, all these values we have got are acquired from the ISA, that is Indian Standard 10,500 of 1991, and from Central Pollution Control Board standards. Again, I am reminding one thing, that this particular column deals with the values, that is allowable limits of each parameter taken into consideration for the calculation of water quality index in case of excellent quality of water. Followed by, this column deals with the allowable limits of each parameter which are taken into account for the calculation of water quality index of good quality water. This column deals with the values of each parameter, that is the allowable limits for each parameter that are taken into account for the calculation of water quality index for the fair quality of water. This column deals with the allowable limits of each parameter which are taken into account for the calculation of water quality index for the poor quality of water. And this column deals with the values of each parameter which are taken into account for the calculation of water quality index for the heavily polluted quality of water. And this column depicts the or expresses the units for each parameter which have taken into account for the calculation of water quality index. That means the unit of turbidity is NTU, the unit of color is Hazen unit, the unit of total dissolved solid is mg per liter, the unit of dissolved oxygen is mg per liter, the unit of BOD is mg per liter, the unit of Secchi depth is meter, the unit of total hardness is mg per liter, the unit of chloride is mg per liter, followed by fluoride, nitrate, total phosphate, iron, sulfate, arsenic. All these parameter has the same unit, that is mg per liter, mg per liter. And for the total coliform parameter, its unit is mpn. So again I am saying that for Indian standards, for the calculation of water quality index, this 16 number of parameters are taken into account, that is turbidity, color, total dissolved solids, pH, dissolved oxygen, biochemical oxygen demand, Secchi depth, total hardness, chloride, fluoride, nitrate, total phosphate, iron, sulfate, arsenic, and total coliform. Altogether 16 number of parameters for the calculation of water quality index. And these parameters have been suggested by IS 10500 of 1991 and by the Central Pollution Control Board. As per the discussion till now, we have understood that water quality index actually reveals the capacity of accessibility of clean and clear and drinkable water of the people at a certain place. That is, how good the water from the water supply is, and based on the water quality index, it is found that Punjab is at the top position among all the states and union territories in India in case of accessibility of clean water, whereas Mumbai tops the list of cities in India, whereas the worst state and metropolitan city are Lakshadweep and Delhi respectively at the water quality index ranking. Our native state West Bengal is at the 8th position as per the water quality index ranking, 2019. So Punjab as a state and Mumbai as a city has got the most accessibility of clean and clear and drinkable water. We have gone through that particular parameters which are generally taken into account for the determination of water quality index. But there are other parameters which are also required for assessing the water quality. As per IS 10500 2012, they are as follows. Here we will go through every possible parameters which are integral part of water quality assessment. So as per this table, as per the Indian standard 10500 of 2012, the requirement or the acceptable limit of color is 5 Hazen units. For the pH value, the requirement or the acceptable limit is around 6.5 to 8.5. For turbidity, the acceptable limit is around 1 NTU. For the total dissolved solids, the acceptable limit is around 500 mg per liter. These values have been acquired from the Indian standard 10500 of 2012. As per this table acquired from the IS standard 10500 of 2012, the acceptable limit of aluminium is around 0.03 mg per liter for a good quality of water, that is for the drinking water. For ammonia, the acceptable limit is 0.5 mg per liter. For the anionic detergents, the concentration, that is the acceptable limit, is around 0.2 mg per liter. For barium, the acceptable limit is 0.7 mg per liter. For calcium, it is 75 mg per liter. Boron, the acceptable limit is 0.5 mg per liter. For chloride, the acceptable concentration is 250 mg per liter. For copper, the acceptable limit is 0.05 mg per liter. Fluoride, the acceptable limit is 1 mg per liter. For iron, the maximum acceptable limit is 0.3 mg per liter, followed by magnesium or manganese. The acceptable limits are 30 mg and 0.1 mg respectively. For the presence of mineral oil, the acceptable limit is 0.5 mg per liter, and followed by other metals and minerals, that is, if silver is there, the maximum acceptable limit is 0.1. If there is any sulfate, then the maximum acceptable limit is 200 mg per liter. If there is hardness, then the total hardness limit is 200 mg per liter. If there is any zinc, then the maximum acceptable limit is 5 mg per liter for drinking water. And again, I am saying that these values have been acquired from the Indian standard 10500 of 2012. Now this table deals with the parameters concerning toxic substances, and the values have been acquired from Indian standard 10500 of 2012. As you can see, if there is any cadmium, then the maximum allowable limit is 0.003 mg per liter. If there is any cyanide, then the maximum allowable limit is 0.05 in drinking water, that is 0.05 mg per liter in drinking water. If there is any lead, then the maximum allowable limit is 0.01 mg per liter. For the presence of mercury, the maximum allowable limit is 0.001 mg per liter. Followed by, if there is any pesticides found in drinking water, then the maximum allowable limits can be as per the table 5, which is shown later. If there is any chromium present, then the maximum allowable limit is 0.05 mg per liter. If there is any arsenic, then the total arsenic limit, that is the maximum allowable limit, is 0.01 mg per liter. This following table deals with the maximum allowable limits of the parameters concerning the radioactive substances if found in drinking water. If there is alpha emitters radioactive materials, then the maximum allowable limit is 0.1 becquerel per liter, and if there is beta emitters, then the maximum allowable limit is 1 becquerel per liter. And this particular table deals with the maximum limit of pesticides if found in the drinking water. So if pesticides are found, then the maximum allowable limits as per the Indian standard 10,500 of 2012 are as follows. Generally, this kind of pesticides are found. If alachlor is found in drinking water, then the maximum allowable limit is 20 microgram per liter. If atrazine is found, then the maximum allowable limit is 2 microgram per liter, followed by aldrin, alpha HCH, beta HCH. So we can see these are the maximum allowable limits of these pesticides if found. So these are the maximum allowable limits of the pesticides which can be seen or observed in the sample of drinking water. Then these are the maximum allowable limits of these particular pesticides. And this table deals with the bacteriological quality of drinking water as per the Indian standard 10,500 of 2012. From here, you can see that no bacteria, that is E. coli, should be found in any kind of drinking water or any kind of water distribution systems. As mentioned, that they should not be detectable in any 100 ml sample. Thank you.